they did not all pour out of the doors every afternoon at 3:30. However, it would be very likely that the men would go to work in a suit and tie and then go to a locker room and change out of their middle-class clothes and put on their work clothes to go work in the factory. Then before they go home, they would put it back on their street clothes. And to wear a nice coat and a hat and a suit would be a demonstration that you were in the skilled working class, that you had achieved some kind of middle-class respectability, even though you were not what at that time would be considered part of the middle class. But there's one guy who's got his overalls on, so. So that's Mr. Westinghouse's self-conception. And it's interesting, he doesn't appear in the film, even in a section that I didn't show you. Because for him, his workers were what made the Westinghouse Company work so well, function. At that time, it was the largest electrical company in the world. So back to the slideshow. So Westinghouse, I'll talk about him first because you probably don't really know about him, was born in Central Bridge, New York, which was a small town about 35 miles west of Albany, so in the center of the Hudson Valley. Westinghouse's father had been a machine shop owner. The father employed a handful of men, anywhere between 3 and a dozen, depending on how much work he had, who worked on the production floor with him and his sons, producing a variety of machine-made products for farmers and other businesses in the local area. He did not, his customer base was probably anywhere within anybody within a 30-mile radius. But a successful and prominent businessman for that small market. During the Civil War, George Westinghouse, his son, the machine operator's son, enlisted in the Navy where he served as an assistant engineer on the USS Mascuda. And after the war, he enrolled in Union College in Schenectady to study engineering. This is very, very common. Many, in fact, probably a majority of the post-Civil War capitalists were college graduates, but primarily from engineering programs. At the age of 19, while studying, George Westinghouse invented this machine, the rotary steam engine. And he attached it to another set of engines, a tractor, and he made one of the first horseless tractors, one that ran on steam. In his effort to sell his inventions, George Westinghouse was offered a job in the engineering department of a railroad company. And this is also another common feature of post-Civil War U.S. capitalism. Many of the most prominent entrepreneurs got their start in the railroad business. And in 1969, George Westinghouse invented steam air brakes, air compression brakes. And then he formed his own company to manufacture and sell his air brake system. This was one, in the history of transportation, this is one of the most important inventions ever. Because prior to this invention, brakes had to be operated manually. So on a train, the engineer knew that he had to slow down. He had to send 3 or 4 men up to the top of the cars, and they would go down the cars, turning the brakes by hand. With this invention, the engineer could stop the train by braking using controls that would be in his engine cabin along with everything else. This meant, and Westinghouse invented this because he had personally witnessed 2 horrific railroad accidents, and he thought there had to be a better way. And this meant that railroads, which had been basically limited to 30 to 35 miles an hour, could now increase their speed up to 80 to 90 miles per hour. This was solving a problem that everybody had thought was insolvable, that the fastest railroads were going to go was 35 miles an hour, maybe 40, and suddenly you could double the speed, or more than double the speed. This was, in a sense, Westinghouse didn't need to worry about market or even how to sell his stuff. All he had to do was produce them in enough quantity. He would sell them to every railroad company in the United States and indeed around the world, because every railroad company would see that they could really surpass the barriers that they had. So he formed his own company, having to get some money from New York City, from Wall Street, to be able to put together, to be able to produce millions of these things on a regular and reliable basis. And this invention really facilitated the rapid expansion of rail lines by solving the problem of accidents, as well as expanding the number of trains that could run at any given time on any given line. So Westinghouse's invention was a hot item, and you might even say it was essential. And it was also a product with an international market. And he became a millionaire at the age of 22. By millionaire, we should translate that into billionaire in today's lingo. His company, so you might think of him as maybe the Steve Jobs of the 1870s. His company then went on to develop and market most of the signaling and switching systems trains used in every part of the world. And he also, as part of this, had to develop a system for how you decide, how you signal that you're stopping, starting, or should go. So the basic red, green, yellow system, the system that then was later adapted to railroads, came out of this effort to develop a way of increasing the speed and the traffic of railroad lines. To the degree that trains were an essential element in the growth of national and international markets in the last third of the 19th century, George Westinghouse played an absolutely central role in making it possible. He invested in railroad companies, of course, but his money increasingly came from developing the infrastructure that modern industry needed both for production and distribution. So he was trying to to overcome the obstacles where businesses were running up against the capacity limitators for doing what they do. So in the 1870s, he pioneered systems for natural gas distribution, which first had to do more with providing an alternative source of energy. And also he developed telephone switching systems based on his railroad switching systems. Telephone. His contribution to telephones made telephone companies possible. So telephones had been, in a sense, a novelty, something that would be demonstrated at World's Fairs, but nobody could figure out how to make them a practical part of business. George Westinghouse developed the the system that allowed businesses to be able to use telephones to call each other, or for central offices of a major company to call their branch offices. In 1886, Westinghouse acquired the patent rights for Nikola Tesla's work with alternating current, as well as several French patents for model power transformers and generators. And his goal was to make large-scale electricity production feasible, a project that required really massive investments spread out across several corporations. He set up about a dozen corporations to handle different parts of the problem, because if one failed, then the others were protected from the failure of that particular experiment. Westinghouse's work on telephones and electricity put him into direct competition with Thomas Alva Edison. And this became one of the most publicized business battles of the 1880s and 1890s, and you can read about it in the Maury Klein book. Edison had been born in Ohio. He grew up in Port Huron, Michigan, just across the border from Ontario. His father owned a farm in Michigan, but really he was a Canadian revolutionary. He had been a leader in the 1837 revolution against British rule of Canada and had escaped to the United States and remained in Michigan trying to instigate further revolutions. At the age of 12, Edison left home to work in the telegraphy department of the Grand Trunk Railroad, which was a Canadian company that connected the Great Lakes states to New England through Ontario and Quebec. Edison learned telegraphy, which was an essential part of how railroads operated and how they were regulated. In 1862, at the age of 15, Edison launched his first successful business venture while continuing to work for Grand Trunk Railroad. He reasoned that people were hungry for news about what was going on in the Civil War. He contracted with over 100 telegraph operators in the war who were working in the war zone to send him daily updates on combat activities in their zones. He compiled this information into daily reports that he then sent to telegraph operators throughout the North to distribute in their towns. So he provided up-to-date news much more quickly than any of the existing newspapers at that time could. In April 1862, when the Battle of Shiloh began, he paid his contacts to send him hourly updates, which he quickly distributed throughout the North on an hourly basis. And he made additional money by buying newspapers from the battle zone that had more detailed accounts of the war, and then using his contacts with the railroads to ship these newspapers to buyers through the North. His work in telegraphy introduced Edison to the basics of electrical science, and he began to work on a variety of small, practical devices that railroad companies and telegraph offices needed. He developed alarms to alert personnel when problems were developing. He developed a weather insulation so that the wires would be able to function about the same level, whether it was hot or cold.